Hello everyone and welcome back to Life in Technologies YouTube channel. I hope you're doing well and thank you so much for watching this session. So this is another episode of our Juniper Lab Simulation series, and in this series we are focusing on how to do route distribution among protocols. So we know that in a network, especially a service provider network, we will definitely have different protocols running on the network. We can have OSPF, so there could be some section of the network that is running OSPF. We have a section of the network that is running ISIS, depending on the requirements. And then, of course, we will have BGP, both IBGP and EBGP. We can have direct routes, we can have static routing, and when you are managing such type of a network, you need to redistribute routes among these protocols. So for example, you have some devices that is in OSPF and you want them to be reachable by a network or by devices that are running ISIS. Or you have devices with static routing and you need these routes to be propagated across the network. So you really need to understand how to do the route distribution between these protocols, and you must follow the best practices. So one of the best practices that you should use is that you should use policies. So on Junipers, we have the policies, and you need to be able to configure these policies. You need to be able to use the route filters so that you specify the exact route that you are trying to control, or the one that you want to be exported or imported into different protocols. So that is one of the basic requirements that you should do as a network engineer. So you can see that in this topology, we have different protocols already configured and running, confirmed to be okay. So we just need to demonstrate to you how to do the route redistribution between protocols from direct to BGP. How do you export or import direct routes from the network on R7? So you can see that on R7 to R6, we are just using direct network. And then we have static routing. So when you have static routing on R7 towards R3, how do you ensure that you can import these static routes into BGP and then they will be propagated across the network? Then we have OSPF. So you can see that R1 and R4, we have OSPF. So maybe these OSPF routes should be reachable across the network. You also need to be able to import OSPF to BGP, and you also need to be able to import BGP to OSPF. Again, you have ISIS, so you have some segment of the network that is running ISIS. How will you do the route importation? So you need to also understand how to do route import or export from ISIS to BGP and from BGP to ISIS, maybe from OSPF to ISIS or ISIS to OSPF. So these are some of the things that you need to practice. These are some of the things that you should be able to do as a network engineer managing a service provider networks. So we've set up the lab in EVNG as it's displayed here. And the first lab, in this lab, we are just demonstrating to you how to import direct routes into BGP. So you can see that between R7 and R6, we only have direct route. So you want this 60.60.60.0/31 to be advertised into BGP. And you should be able to get this route on R2 and also on R1, because these are BGP routers. So once the route is imported on R7 into BGP, you need to be able to propagate it to R2 because that is BGP, so it will be advertised through the eBGP. And then R2 should be able to advertise this route to R1. And we should confirm that that route has been advertised to R1. So I will quickly log into the lab. So this is the lab setup in EVNG, same that we've displayed. And when you log into these routers, so you see that on R1 we have IBGP, we have OSPF towards R4, we have ISIS towards R5. So if you show router, let me quit, show OSPF neighbor, on R7, no, this one we need to be on R1. So on R1, if I show OSPF neighbor, you can see that we have an adjacent towards 40.40.40.1. And if I show OSPF route, you see that we have some OSPF routes. Again, if I show ISIS, adjacency. You can see that we have adjacency towards R5. If I show route protocol ISIS, you see that we have one ISIS route. So we have only advertised that loopback towards on R5 into ISIS. So you can see that on this R1, we have this as our ISIS route, and we will be demonstrating how we can import this route from ISIS to BGP. And then if you show BGP summary, you are also able to see that we have an adjacency. And again, if you show route, just all routes, you see that we have direct, we have ISIS, we have OSPF, we have local routes. So everything is running on R1. And then if we check on R2, we expect to see the same. So on R2, we have BGP. So if I show BGP summary, you will see that we have two sessions. We have one iBGP session towards R1, and we also have an eBGP session towards this is R7. So we have the routes there. If we check the routes, show route, you see that we only have direct routes or local routes on R2. Then on R7, so we've already discussed how to configure these protocols. Maybe if you've missed some of our sessions on how to implement these protocols, you can just check out the previous sessions and you will understand how to configure BGP, how to configure OSPF, how to implement ISIS, and even how to configure static routes as we discussed in the last session. So on R7, if I show routes, you can see that we have static routing towards R3. You can see that we have direct routes, and these are the routes that we want to import to BGP. Again, if you show configuration display set, you will be able to get all the configuration. So you can see that we are configuring the interface parameters, we are configuring a static route, and we are establishing eBGP session towards R2. So these are basic configuration that we've already discussed. So on R7, we want to ensure that 60.60.60.0/31 is imported into BGP. So we've mentioned that one of the best practices that you should use is to use export policies. You need to configure export and import policies, and you should use the route filters or the prefix list to control what is imported into BGP. Just a simple example, if I were just on R7, so let's log into R7. We've confirmed that on R2 we don't have the route to 60.60.60.0. Let me show that again. So on R2, if I show route, you see that these are the routes that we have. I'll go back to R7 and go into the configuration mode. So into the configuration mode, if I need to import direct routes to BGP, so I'll set policy options, and then we need to configure the policy. So the policy statement will be direct to BGP. We can just specify to eBGP or just BGP. And then we need to term 1. So you can name the term, of course. It's better to give it numbering. So term 1, and then we just say from protocol direct. So once we've specified that we are only importing the direct routes, I'll click enter, and then I can recall the same command and just say then accept. If I show pipe compare, so we've configured the policy and specified that we only need to import direct routes, and then the action is accept. So another good practice that you need to do is you must have a reject at the end of your accept statement. So we can recall the same statement and give it term 2 and then say then reject. So if I show pipe compare, you will find that we have two terms. We have term 1, accepting direct routes. So the good thing about specifying the protocol, for example, we say that from protocol direct. So we are very specific that we are only importing the direct routes. If you are importing from OSPF, of course, you will see in the subsequent session that we will use the OSPF. So we are very specific that we are importing the direct route. So we haven't used any route filter. So if I do commit and then I go ahead and use this policy to BGP, so I'll set protocols, BGP, and then there is a group that we've created. The group is eBGP, and we use the export policy and call this direct to BGP. So again, I'll do commit. So we are importing these routes to BGP and they'll be advertised. So now if I go to R2 and run the command show route, you can see that we have so many prefixes that have come in. We have 60.60.0, and again you can see that we have also 50.50.50.0, but we don't want this 50.50.50.0 to be imported into OSPF or into BGP. We just need 60.60.60.0. All the others should not be imported into BGP. Or maybe due to sometimes we want also these networks in the static routing to be reachable, you can also go ahead and implement the import these routes into BGP. But for this case, we only want 60.60.60.0/31. But if you check on R2, you can see that all these prefixes, the direct prefixes, 60.60 has been imported into BGP, 50.50 has also been imported into BGP, which is not the case that we want. So this is not what we are trying to achieve. So what we want to achieve is to only have the 60.60.60. So that's where we use the route filters or the prefix list. So many times on Juniper we use the route filter, and the route filter will allow us to specify the prefix that we want to advertise. So I can go ahead and if I show run, just run show config display set, we can modify our policy to specify the prefix that we want to import to OSPF. So you can see that we have these 3 lines. So we can go ahead and set policy options, policy statement, it's direct to BGP. We are still in term 1, and then I will use from. So I'm specifying. If you use from, of course, you have so many parameters that you can use. You can see community, you can see tags, you can see route filter, you can see prefix list, but in this case we are just using a route filter. Later we can use an application where you can use the prefix list. So we specify from route filter, and then I'll give it 60.0/31. Then we can specify this is just exact. We only need this prefix to be imported. One of the things that you need to do and ensure that is correct is this prefix. You should ensure that if you have it in your routing table, then and you are using exact, then it should be /31. If it's maybe /32 or it's /24, then it will not be imported into OSPF. So you need to ensure that you check the prefix that you want to export, ensure that you've matched the mask, unless you are using maybe or longer or other options. You have multiple options here. You can see that you have exact, you have longer, you have or longer, you have prefix length range, you have up to. So you can use them depending on the goal that you're trying to achieve. So for me, this one I just use exact, and then I'll commit. So once I commit, now we expect that on R2 we should not be getting this 50.50.50. We should only get this 60.60.60.0/31 as the prefix, and you can see that that one has disappeared from our routing table. Even there was, let me just expand this. So when you check up here, these were the prefix before. You can see that we were, let me see again. So when you run show route, you can see that we are now not getting the 50.50, we are getting 60.60. So that route will be propagated to R2, and then R2 will propagate that route to R1. So there is a principle of how BGP advertises routes. For example, remember that between R2 and R7 is eBGP. So when R2 gets this route and it's advertising to an iBGP neighbor, it will not change the next hop. So when you check on R1, you don't expect to see these in the routing table, but it will be there. You just need to make some changes and then this route should be installed in the routing table. So if I do show route, protocol BGP, you see that we don't have any BGP routes. If you do hidden, you see that we have 60.60.60.0/31, but it's unusable. Why? Because when this route is advertised, if you do extensive, when this route is advertised to R1 from R2, R2 is advertising the next hop to be 20.20.20.1. Remember, iBGP doesn't change the next hop parameter. So there are some changes that you need to make for you to be able to ensure that R1 should be able to reach this network. So maybe in the comment section, before I give my answer, you can tell us how you can ensure that when R2 is advertising these routes to R1, R1 will accept this route and the route will not be hidden. So as of now, you can see that this route is hidden. When we do the hidden, then it's hidden. If I just show route hidden, you can see that this route is hidden on the routing table, and the issue is the next hop is unusable. You see the next hop is 20.20.20, which is the interface between R2 and R7, and 20.20 has been configured on this interface, the one on R7. So R1 doesn't know how to reach this next hop. So how do we fix this issue? Maybe you can tell us in the comment section, but later we will be discussing how you can fix this, because the focus on this session is just to explain to you how we can import direct routes to BGP. And from the configuration, you can see that we've achieved that. On R2, we have the route. We should be able to ping 60.60.60.1. Of course, this one will not be reachable, but .0 it's on R7, and you can see that this is reachable from R2, which was the goal of the session. So on R7 again, if I run show configuration and then display set, you can see that we've configured a policy. It's always a best practice to use policies. Don't just export or import everything. You may have loops when you are doing redistribution of routes in your network. So you really need to be specific on what you want to be exported or imported from one protocol to another. So we created a policy direct to BGP, and then we gave the terms. So it's always good to have different terms, and sometimes you also need to give some spacing. So you can have term 1 and then maybe term 5, so that when you want to insert a new term, it will not bring any confusion in the numberings. So you create it, and then you always have to have a reject. So by default, you will have a reject statement, but you can configure it on your router. This is one of the best practices that you should use. So we create a route filter for this specific route that we want to be exported to BGP, and then we apply it on our BGP export policy. So this is it, guys. I hope you've enjoyed this session. I hope you now understand how you can import direct routes from on your MX routers and export them to BGP or advertise them to BGP so that they are reachable. Again, our networks are always complicated with all these different protocols running on them concurrently, and you need to be able to do this route redistribution between protocols just to ensure that you have reachability between different nodes in different segments of the network. Thank you so much for watching this session, and I hope to see you in the next episode. Again, just remember to comment, to like, and tell us how we can fix this issue of reachability. So we want to ensure that R1 installs this route in its routing table. How are we able to do that? You can tell us in the comment section how we should fix this issue and ensure that when R2 is advertising the routes to R1, it can use itself as the next hop so that R1 will not see the next hop as unusable. Thank you so much, and again, remember to subscribe to our channel and stay tuned in for more upcoming sessions. See you in the next episode.